Hello everyone. Field-oriented control, also known as vector control, is a calculation-intensive algorithm for motor control which is now practical due to advances in power electronics and integrated circuits. It offers improved efficiency along with superior control of torque and other performance parameters. Today, we will present the whole model of the indirect field-oriented control for an asynchronous machine in detail. This is based on the digital control model as a realization of a system for indirect vector control of an induction motor using digital current control and the three-phase inverter controlled by a PWM signal. These two blocks describe the electrical and mechanical subsystems of an induction motor. The block IFOC is the realization of indirect vector control. This means estimation of the position of the rotor-flux and determination of the references of the stator components of the current based on the measurement of the rotor shaft position and the reference values of torque and flux. This subsystem is the realization of digital current regulation using PI controllers with crossing signal action based on the current error, which is the difference between the reference and the measured values of the stator current components. This regulator calculates the voltages that need to be achieved on the motor phases. This block has the role of taking known voltage references and generating control signals in the form of a PWM signal, which will control the three-phase inverter. The inverter will then generate voltages similar to the references due to the regulation of the current in the DQ coordinate system, as well as the used motor model and the real currents of each stator phase, A, B, and C. To control each phase individually through the three-phase inverter, there is a need for transformations of current and voltage signals, from real ABC to imaginary DQ and vice versa. These transformations are realized in these two blocks. Due to the digital current regulation, which is executed in the microcontroller, it is also necessary to measure analog quantities, meaning the three-phase currents and the shaft position, and convert them into the discrete domain. This is achieved by A to D converters, implemented in the form of ADC conversion blocks. Now, only the internal structures of these models remain. So that we don't make the video longer, we will cover these in detail in the next video. By the way, we have also presented these models and algorithms extensively for both synchronous and asynchronous machines, using Simscape library components and MATLAB embedded functions for the controllers.